Hello everyone, welcome to Learn Overflow. In this video, we will look into today's LeetCode problem, that is the minimum cost climbing stairs. This is an easy level LeetCode problem, so we'll look into multiple approach or multiple ways to solve this problem, multiple ways to be exact, like a recursion or doing with RDP approach, or we'll try to optimize our code as well. So we'll look into the multiple approaches into this. Okay. Further, let's start this video with understanding what the question is all about and how we can think on a question like this. So it's given like we are given an integer array cost. This is like the only stuff given to us, integer array cost. And it says the cost of I is like the cost of the ith step on a staircase. So it means like there are say multiple staircases you have, okay? And like each staircase has a specified cost, that is the cost of the ith position of the staircase is mentioned in the cost of I. Fine. And further it says once you pay a cost, with a cost, you can either climb one or two steps. So say you are at this position and you pay the cost, whatever is the cost over here. Once you pay the cost, you can either climb to one step, okay, or you can climb to two steps directly to this position. So it's up to you how many steps you want to climb. You can either climb one or two steps. So also it further says you can start from the step, like you can start from step with index 0 or index 1. So you can start either from index 0 or from index 1. So it's your choice from where you want to start. So that means to be exact, if you think on this logically, say you are somewhere not on the staircase, so you can start by putting on a step on step 0, or you can start by putting a first step on step 1. So something like that, what they try to mean. So just to have a common sense, like common understanding of the whole problem. Now, further it says it is the minimum cost to reach the top of the flow. So we need to reach the top of the flow. That's the top over here. Okay, that's the top over here. We need to reach here, and we can start from any 0 index or 1 index, and we need to reach the top of the flow. And what do we need to find? We need to find the minimum cost. The cost, how is it being calculated? We find that once we pay a cost as it's at each stair, whichever we put our step on, right? So if we need to find the minimum cost, then think carefully. We need to have a like once again we need to look for a minimum cost, the minimum value, like minimum for our case, right? But look carefully. Can we do it on a greedy approach? Like we need to be come up with a minimum. So can we do it in a greedy approach? Let's see. Say you have a 10, 15, and 20. So these are the three stairs you have. And if you go ahead with a greedy approach, what would be your answer? Your answer, you will definitely try to take up 10 in the beginning, right? Because that's the minimum you have and you are greedy about reducing your cost. Then you took the 10, and from 10 you can either go to 15 or you can go to 20, but you cannot go like top of the stair, that is move ahead of the stair, right? It is the top. So in that case, how can you go? Like first step you put in at step 10, like 10, and then you want to reach the top of the stairs. For that, you either need to put a step on 15 or you need to put a step on 20. Like if you put a step on 15, then you can put like from 15 you can reach the top of the stair. Or if you directly put a step on 20, then you can reach the top of the stair. So with our greedy approach, with being greedy that we need to minimize our cost, we put up our first step on 10, but we see that we cannot like reach our ultimate destination, right? And that cannot be possible. So we somehow realize that greedy is not the way to solve this kind of problem. What can we do over here? We simply can yeah, we simply can go ahead and try to look into this problem in such a way that whatever be the cost at our current position, we need to look like we need to have a table for the previous cost, like previous two steps. Say we are at position 20, okay, and like at position 20, and from here we need to see what is the minimum. Like if we reach position 20, then we are sure that we can reach either from position 15, right, or from position 10, like stair which is at position 10, right? So at 20, what can be the minimum cost? Like if we put a step on 20, then what can be the minimum cost to be on 20? The minimum cost will be 20 plus a minimum of its last two elements, right? Not exactly last two elements. To be more precise, what is the like minimum of like cost at last two elements. Like it may happen like before 10 there are some steps. So let's take an example. Let's say 1, 2, 3, 4, 5, 6. Okay, just 6 elements. Now let's understand how we can go ahead with this. We like if we can have two options. Okay, we can have either two options. Say we can start from index 0 or from the index 1. Fine. So if we start from index 0, our cost will be 1. If you start from index 2, our cost will be 2. That's fixed. Like it's fixed for us. Like whenever we start, our cost will be that much. Now for index 3, like whenever we are at this index, what can be our cost? Our cost can be either like we need to pay a like we need to pay a cost of 3. Fine. Plus, what do we need to pay? We need to either pay a cost that is at this previous index, or a cost that is at 2 index before it. Fine. So we need to find a minimum of this two, not this exactly, rather minimum of the cost that we have to pay for this. Fine. For 3, we find 3 plus a minimum of this two is what? 4. Minimum of 1 and 2 is 1. So 3 plus 1 is 4. So that's the cost we need to pay. Minimum that cost to reach step 3. Fine. Now we are at step 4. So for step 4, what we need to do? We need to go ahead with the minimum of this two. Fine. What can be the minimum of this two? Say you are like 4, we need to pay the 4th step, and either way we can reach 4 by stepping into the last, like any of the last 2 steps. So we need to find the minimum here. The minimum of 2 and 4 is 2. So 4 plus 2 will be the cost we will be paying over here. Okay. Moving forward, we are at step 5. Fine. Now for this step 5, we have like we again need to pay a cost that is the current cost added to in like the minimum cost of the last 2 stairs, because we can reach 5 either by stepping in 3 or by stepping on 4. Right? That's those 2 stairs. So what is the minimum cost out here? Like to be exact, what is the minimum cumulative cost? Being like there are other steps behind it. So what the minimum cumulative cost out here? Minimum cumulative cost you can find is like 4 over here. So when it's 4 over here, so we'll do 4 plus 5 will be the 9 will be the cost we'll be paying to put a step on a step 5. Okay. Next we are at step 6. Fine. Now for step 6, what will be the minimum cost over here? The minimum cost will be we need to pay the price at this particular position, like at this particular 6, right? And the cumulative minimum cost of the last 2 steps. Like we can either put a step on 4 and then put a step on 6, or we can put a step on 5 and put a step of 6, right? So what is the minimum? The minimum will be minimum of this two. What is the minimum of this two? The minimum of this two will be 6. So 6 plus 6 will be 12. But what our question says, we need to reach the top of the floor. So we need to reach at a position like this. Fine. So once we need to reach a position like this, so we can reach a position like this by putting a step from 12 to the next one, or by putting a step from 9 to the next one. So our ultimate answer will be something like 9 being the minimum cost we can have. So by after putting a step on 9, then we can climb to the top of the floor. That's what we did here over here. If I just show you in the example 1, what exactly is shown here, like 10, 15 and 20 are there. So the expression says you will first start at index 1. So it says you can start at index 1 as well. And then pay 15, like you need to pay you say once you pay the cost, you can either climb 1 or 2 steps. Fine, pay 15 and then climb 2 steps to reach the top. So one step will be on 20 and the next step will be the top of this, like is the top. So what exactly it means? It means we need to reach the end of the array. Fine. To be exact, if you think on an array point of view, we need to reach the end of the array. So the total cost is 15. So that's the idea we are looking forward over here. Okay. Now let's understand example 2. Like it is the same exact example, but let's understand once and we'll look into the solution. Fine. So it says like there are like 100, 1 on 100, 100 and 1. Okay, so these are the values given. So it says like we'll start from index 0. Why index 0? So the first thing we should go ahead with, we should find a minimum of this. Fine. A minimum of the index 0 and index 1. So whatever is the minimum, we can start from here, or we'll look into in much depth in our code over here. Okay. So for this place, it says we start from index 0 and then we pay 1 and climb to index 2. Like we pay at this position and climb to index 2 at this position. Fine. And then we again pay 1 and climb to index 4. Like we can see, we can go over index 4. So we pay 1 and go over there. And then we again pay 1, like the index 4 payment, and climb to index 6. So we go over here. Fine. and then you go to the index 7, and then you move to index 9. Fine. From index 9, we can actually climb to the like pay 1 and climb to the top. So ultimately, it's just like the 6 being the answer that we are paying over here. So we'll keep a track of the minimum of the last two values and keep on putting our step forward, right? So if we look carefully, so if we find the min cost, okay, I'm marking as min C, a min cost at any position I, fine. At any position I, our min cost will be what? Our min cost will be this cost of I, okay, say this particular cost of I with added to, if we just look carefully, what will be what? Our value. So a min cost or at position I will be the cost of I that we are adding, added to our min of our min cost of I minus 1 and I minus 2, fine. So min C of I minus 1, comma, min C of I minus 2. So there we are finding the minimum of this two value, fine. This is the bracket I mean, okay. So min C of minimum of I minus 1 and I minus 2. So that will be the minimum cost at this position. So added with the current cost value. Fine. So this is the recurrence relation we can find, and we can keep on traversing our array on this format. Okay. So if we look for like min C 0, if we just mark it, okay, min C of our 0th element will be what? Cost 0. Fine. Will be cost 0. Those are the best cases. Fine. With just the array cost array with value 0, fine, and eventually wins of cost 1 will be cost 1, fine. That will be the best cases. Now once we see for a formula like this, and once we find our like base case as well, so the first thing we can go ahead with say directly I will just type it as well. So the first thing we can go actually with an recursion. Recursion in the sense that if our n being the position at which we are, if it's less than if it's less than our given 0 or 1, like less than 2, you can say, then return the particular cost value. Else, if it's else, you should return the using this formula, right? So that will be our minimum cost. Like if to be exact, if we start from this function, like minimum cost climbing stairs function, then we can directly say find the minimum cost at value n and n minus 1. Fine. That's what we can do, and ultimately return the value. But remember, like whenever we do something like this, we will end up finding a recursion tree. Like we'll breaking into each of the costs and finding the minimum at each position and then returning the cost for us. This is kind of like whenever we are using recursion and we are breaking into two parts, like one is over here and one is over here, and every recursion it will break into two parts and keep on breaking. So this will this reconciliation will end up having a complexity of 2 to the power n, like okay, order of 2 to the power n. Like there is a chance, I'm not sure whether it will get or not, but there is a chance that you may get a time limit exception once you try to do this using recursion. So whenever we know our formulation, but we are getting a like time limit exception or kind of is not working, then the thing we should go ahead with memoization or particular values we have at this position. Fine. So how we can do that? We'll go ahead with use DP in this case. Okay. So this is more or less the formulation we have. So keep a note of this, and we will keep using this further in our solution. Fine. Now let's go ahead and write this code. What we are thinking of doing it right now. Okay. So we will go ahead with simple DP, bottom of DP rather, and find a solution to that, like the exact way we were seeing it on the diagrams. Okay, so we'll do it in the similar way. So first thing is just take our n being the length of the like cost array length. So we can find a like limit of how much we need to do it. Then we will go ahead with a DP array, not a DP array, a lookup table rather, so that we can keep our current cost, keep a track of all the cost we have. Okay, fine. Moving forward, what we need to do, we will simply do a single pass for like exactly if we'll do a single pass on the whole loop. Fine. Uh, on the whole cost array. So it will be like from I equal to 0 till I less than or n, and then I plus plus. That's our whole pass we'll go ahead with. And over here, we need to keep a check, like if I is less than 2, that's the best case. You need to remember that those are the cases when exactly we are choosing like index 0, index 1. So that we are keeping. If I is less than 2, then we'll do dp of I is simply dp cost of I. Fine. That's the base case we calculated over here. And in the else will be our exact formulation that we found out. So it will be the dp of I equals a cost of y added to math.mean of our exact values we have. Okay, math.mean of dp of I minus 1 comma dp of I minus 2. That those are the two values we look forward to, and we simply find the minimum out there, and we will pass to the whole loop, and we find a cost of error. Okay, and ultimately return what? Return our again math dot mean. What will return? dp of n minus 1, or like n minus 1, or dp of n minus 2. So those are basically the last two elements we, as I showed in the example like previously. Those are the last two elements we have over here, and we'll simply find the solution based on that. Fine. Now we will go ahead and run this and try to see if this works for us and what's the complexity and all, because the complexity you can see is like order of n we have. And let's submit the answer and try to find out what's the answer we have. So it's a 2ms solution. Yeah, it may vary at times, like it's a 2ms, 1ms. Like if you run it again, it may submit in a 1ms. Fine. So this is all the question is all about. Okay, so this is what we need to do, and this works pretty fine for us as well. So that's the question we have, and that's how you can solve this problem. So